Hi there, welcome back to another math video. In this video we are studying the right triangle. Trigonometry is the study of right triangles. And this particular right triangle is not locked into any particular size. It has one 90-degree angle and two acute angles, which will be complements of each other. And let's look at the title for the video. Trigonometric ratios. These are comparisons of side lengths of right triangle. The acute angles are reference points for either adjacent or opposite leg locations. Let's find acute angle A. Here it is. When we are using angle A for our reference angle, we now have an opposite, and remember when we're going across the triangle, that gives us the opposite leg, which would be A, right? And this is a convention also. The lowercase a is always opposite the capital A. Leg B is the adjacent leg. Let's hide angle A, and now let's focus on acute angle B as the reference. If we're working with this angle for trig ratios, now it's side B, which is the opposite. This is the opposite leg, and side A is now the adjacent leg. The longest side of the right triangle, which is opposite the 90, is the hypotenuse. And there's only one of these, so it only has a single roll. C is the hypotenuse. Here again are the appropriate names for the legs for each of the acute angles in this right triangle. And what we want to do now is introduce sine, cosine, and tangent. These very famous ratios are simply comparisons of side lengths. We just make a ratio. For sine of an acute angle, we take the opposite leg and we divide by the hypotenuse, or we compare those two distances. For the cosine ratio of an acute angle, we take the adjacent leg and we divide by the hypotenuse, or compare their two distances with division. For the tangent ratio, we compare the opposite leg with the adjacent leg. And this acronym, SOHCAHTOA, this is used by all kinds of math classes and math teachers all over the place. Notice that the capital letters sine equals opposite over hypotenuse gives us our SO. Cosine equals adjacent over hypotenuse gives ka, and tangent equals opposite over adjacent is toa. Maybe it will be helpful. I think for most people it is. Let's look at a few examples of trig ratios. Let's say I want to find sine of angle B. This is how we would read this. Sine of B. This is the abbreviation for sine. Well, what I would do is first I would find angle B. That's a very important first step, is to locate the angle. Then I would make my opposite calculation over my hypotenuse. So sine of angle B is B over C. Let's write an equation for cosine of angle A. So this would be written COS. That's the abbreviation for cosine. It's a lowercase, as was our abbreviation for sine, a lowercase. Cosine A equals, well, first locate angle A. Cosine is adjacent over hypotenuse. So that would be side B over side C, C being the hypotenuse. And now let's find tangent of A, again lowercase t. Okay, back to angle A. Tangent is opposite over adjacent. Opposite over adjacent, forget that. So tangent A is side A over side B. Opposite leg over the adjacent leg. Let's do a little sample problem where we're given actually a Pythagorean triple, the most well-known right triangle, the 3, 4, 5. And what we're asked to find are the trig ratios for angle B. So let's start with sine B. First, let's locate angle B. Sine is opposite over hypotenuse. So sine B is 3/5. Now we want cosine B. Cosine B is adjacent leg over hypotenuse, which will be 4/5. And our last trig ratio is tangent B. And tangent is opposite over adjacent. The opposite leg 3 over the adjacent leg 4. If we were to use your calculator to calculate sine, cosine, or tangent, it is going to give you a decimal, so it is also important to be able to convert your ratios into decimal form, which we also have now. Sine B is also 0.6, cosine B is 0.8, tangent B is 0.75. And let's also find trig ratios for angle A. So first locate angle A. Sine A. Sine is opposite leg over hypotenuse. 4/5, which is 0.8. Cosine A. Cosine is adjacent over hypotenuse, which is 3/5, also 0.6. And tangent A is opposite leg over adjacent leg, which is 4/3, which is 1.3 repeating. And our last sample. We have a little situation here, a little word problem that says the angle of elevation from a point B to the top of a building, so this is our building right here, this large rectangular shape, and this is outside the building, and this angle of elevation is 70 degrees, measured in a positive direction. And point B is 20 feet, that's this green distance, from the base of the building. So how tall is the building? H. Alright, so we are going now to make an indirect measurement using a trig ratio. So for the procedure, we will use the tangent ratio for angle B in order to make an equation. I'm solving for the opposite leg, I'm given the adjacent leg. So since I don't know the hypotenuse and I'm not trying to find it, I would not be using sine or cosine since both of those ratios involve the hypotenuse. The tangent involves only the opposite and adjacent legs. So my first step, set up an equation. Tangent of angle B is the opposite over the adjacent. Then substitute. Angle B is measured with 70 degrees. H is the missing value I'm trying to get, and 20 is the adjacent leg. Multiply both sides by 20, and then it is time to get out the calculator. Now when solving trig problems on your calculator, always check your calculator mode. There should be a choice between at least radian and degree mode, and right now I'm working with degrees, so I'm going to make sure I'm in degree mode on my calculator, which I am. And now I will input 20 multiplied by tangent of 70 degrees. And the decimal I'm going to round to the nearest foot, which is the nearest whole number, the nearest unit, and that is 56 for H. So my answer here is 56 feet. Alright, thanks for watching. Keep practicing.